Hello, welcome back to this class, Kiko Search Algorithm, Part 4. This is again a practical part. Uh, I can show a simple example on how we can implement Kiko Search, uh, modified version, not the Lévy Flight, on a simple optimization problem. So, yeah, this is a simple example. Um, Here we have a fitness function. Fitness function, we have it uh, x1 and x2, two dimensions, both of them square, sum them up, and the range of x between 0 and 5. So x1 between 0 and 5, uh, x2 between 0 and 5. So x1 is 4 by 1, the solution x1, it has two dimension. X1 is 4, x2 is 1. Likewise, x2 second solution is 2 by 3, and x3 5 by 2. Now we plug them into this function, So 4 square, uh, uh, 16 plus 1 square, 1. It will be 16 plus 1, 17. Likewise, 2 by 3, we plug them into this equation. 2 by 3, plug them into this equation. So you'll have 13. And 5 by 2, again, plug them into this equation. You will have 29. Now we take the minimum, 13. That is our best or global solution. So let's walk through the algorithm pseudocode. Here we initialize, randomly we initialize it, evaluate fitness function, determine the best fitness, while stopping criteria is not arrived. We do a loop. We go through the solutions that we have, the three solutions, xi, and move toward best solution using this. That's the updated equation. And we evaluate it. And if it's better, we keep it, we replace it, and we keep the best solution. And then this will go for the second one and third one until the loop is ends. And then the while loop final iteration is met. We stop there and we return the best solution. So here is the updated equation, how to update the next solution equals the current solution plus zero point 0.8, this is C factor, C attraction factor multiplied by difference between the global best minus the current best. So that's the best solution that we have in the iteration 2 by 3. And then X1, we have 4 by 1. We plug them into updated equation, and we try to find the X new value. That's the updated equation. So 4 by 1, that's 4, and that's 2 minus 4. So here, this is the equation, and you plug into x1 into that equation. So that's the result, and the fitness has changed to 12.52. So that's the first I. We'll do it for the second I. The second I cannot be changed because it is the best itself. So if you go to the second solution, that's the best we have. That is the best we have. 2 by 3 is the best we have. That's minimum. That's unchanged. Let's say unchanged. And then for I3, 5 by 2, x1 is 5 and x2 is 2. X1 is 5 and x2 is 2. Plug them into updated equation. So you'll have 2.6 and 2.8 for x3 new solution. Now we have the fitness 14.6. Now we kind of at the end of second iteration, we just do statistics. X1 is 12.52. X2 is 13. It was the best, but now it's no longer. And X3 is 2.6, 2.8, it gives you fitness 4.6, 14.6. Now we keep the best solution 2.4 by 2.6. So in iteration 2, this is the best solution now. It has been changed. So 2.4 and 2.6, X1 and X2, that's the best fitness that we have. So we keep that fitness. For X1 is not any more changes because that is the best fitness that we have. For X2, we plug them into updated equation. So, and we will receive 12.43. That's X2 new. And X3, I3, the next solution agent, let's say next Kiko or next nest, X3, 2.6, 2.4, we plug them in and we find 12.88. Now we will see end of iteration. That was the best solution that we have, but now it's no longer because this is less. So that's our best solution and we keep it. And you can see the fitness function has minimized the solution. So this is the best fitness that we have. Some comparison between the original CS Lévy and modified, which we work with this one in this class. So modified is more deterministic convergence, less random, while here it has random global search. And in the here we have 12.3. In earlier class that we discussed Lévy flight, it was 9.31. This one low in terms of exploration. This is high because it has a lot of Lévy random. Remember, we had beta, we have U, we have phi, and we have alpha. Convergence speed, this is fast and shorter. This is moderate. Escaping local minima, this is weak. This is strong. And diversity, this is high. This is low diversity because then it gives you more options and it goes to global search as well. So here, more or less about the conclusion. Original CS Kiko search, it's more about exploration using Lévy jumps or Lévy flights. Modified without Lévy, more aggressively converges toward current best. Uh, Both behave very differently, even on the same problem, and we apply the same problem to both of them. This is more or less about the Kiko search, and we had four parts. This is last part. Stay tuned with more examples on metaheuristic algorithm. Thank you very much.